again, Mathletes! Welcome to another session of Learning Mathematics. I am Ma'am Aika, and I am your grade 10 mathematics teacher. For today's video, we will discuss about permutations. This is the week 2, quarter 3 for grade 10 mathematics. Let's start first with our objectives. First, illustrate distinguishable and circular permutation of objects. And second, solve problems involving permutations. Now I know you are excited for these lessons, but before we move on, let's have first a review of what we have discussed. Remember permutation? Permutation is an arrangement of objects where order matters. We also use the formula permutation of n objects taken r at a time equals n factorial over the quantity n minus r factorial. This permutation is also known as a distinct permutation or linear permutation, where objects are unique. Objects are distinct. Iba-iba. Now, what if objects are not unique? Or what if objects are not arranged in a row? There are other types of permutation, the distinguishable and circular permutation. Yes, there are 2 lessons for this video. So join me and let's learn these other types of permutation. Let's start off with the first one, the distinguishable permutation. This is the arrangement of objects where some objects are identical. Yes, may parehong object on our options. The formula to use for this permutation is permutation equals n factorial over a factorial, b factorial, c factorial, and so on, where n is still the number of objects, while a, b, c, and any other letters could be the number of repeated objects. Don't worry, this will be easy. Let's have an example for us to use this formula. Example 1. Find the number of permutations of the letters of the word check. Yes, you see it right. There are 2 C's for the letters in the word check. But let's solve it first, assuming that the letters are distinct. So, we have there n equals 5 and r equals 5. Remember, when n and r are equal, we simply use n factorial. So we have there 5 factorial. There are 120 ways to arrange those 5 letters. However, we have to take into consideration the 2 C's. In order for us to differentiate, I use a capital C and a small c. So for the first arrangement, we have there capital C, H-E, small c, then capital K. Or it could be the small c, then H-E, capital C, and K. Also, we can have this arrangement capital C, small c, H-E-K, or small c, capital C, H-E-K. It could also be H, capital C, small c, E-K, or H, small c, capital C, E-K. Take note, we have there 2 C's, small and big, but in reality, they are just the same. Therefore, this arrangement is actually just the same with this one. Also, another pair of arrangement are just the same. And also this one and this one. So there could be more of the same arrangement in this problem. So because there are 2 C's, we now have to get its permutation. There are 2 C's, so n and r will be 2. And n factorial will be 2 factorial. Therefore, 2 ways. This number will be used to divide our original permutation 5 factorial. So in this way, we now have 120 divided by 2, which is 60 ways. So there are 60 unique arrangements of the letters from the word check. Again, distinguishable permutation is the arrangement of objects where some objects are identical, like the arrangement of the letters of the word check. So now applying the formula, n is equal to 5 because there are 5 letters on the word check. And instead of using A, B, C, we will just use 1, which is A, that represents the letter C because there are 2 C's on the word check. Then substitute to the formula, you now have 5 factorial over 2 factorial. So that is 120 divided by 2 times 1. And we now have the permutation of the distinguishable objects 60 ways. There are 60 unique ways to arrange the letters of the word check. See, it might look complicated, but it's actually easier. Now let's try this second example. You can use your paper and pen and join me in solving the problems. How many different permutations are there of the letters in the word Mississippi? How many different permutations are there of the letters in the word Mississippi? In doing this problem, you just have to be careful in counting the number of repeated letters. So, let's start. What is our n? Our n here will be 11 because there are 11 letters. And we will be using the letters A, B, C. A will represent letter I. And counting, we have there 4 I's. B represents the S, and there are 4 S's. And C for the letter P. There are 2 P's in Mississippi. In this problem, there are a lot of factorial notations that you can see. So if you have your calculators with you, please use. If you do not have, you may get it first. And let's solve the problem. So, expanding our factorial notations, we have 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. I did not expand 4 factorial because on the denominator there is 4 factorial. I'll just expand the other numbers. So 4 factorial times 4 times 3 times 2 times 1 times 2 times 1. If you do not have your calculators with you, don't worry, I will help you. Let's start canceling common terms on the numerator and the denominator. So cancel 4 factorial. What else can we cancel? 8, which is also equal to 4 times 2, right? What else? We can also cancel 6. That's 3 times 2. And the simplified form for your permutation is 11 times 10 times 9 times 7 times 5. So you can do this manually, or you may use your calculator with you. So the total number of different arrangements for the word Mississippi is 34,650 ways. Yes, there are a lot of arrangements given there is a big number for our n. Diba? Daming choices. I hope you are doing great with me in solving this problem. Well, I guess that is so easy. Why don't we try the 30 seconds challenge? Maybe you can do this faster than 30 seconds or even longer if you are solving it manually, but it doesn't matter for as long as we know how to solve the problem. Let's start with the first one. In how many different ways can 4 blue balls, 2 white balls, and 6 yellow balls be arranged in a row? 30 seconds, go. Time's up, mathletes. The answer here is 13,860 different arrangements. So let's check if you did the same thing with me. So let's show the solution. Again, for the formula, we now have n factorial over a factorial, b factorial, c factorial, and so on. Remember to take note of your n and the repeated objects. N is the sum of all the objects that we have, which is 12. A represents the blue balls, and there are 4. B represent the white balls, and there are 2. And C, the yellow balls, there are 6. So using these numbers, let's substitute it to your formula. We now have 12 factorial over 4 factorial, 2 factorial, 6 factorial. So you may do this by using your calculator. If not, join me as how I simplify the numbers before multiplying it. So for the expansion on the numerator, we have 12 times 11 times 10 times 9 times 8 times 7 times 6 factorial. I stopped at 6 factorial because I have a 6 factorial on the denominator. So the other factorials will be expanded. We have there 4 times 3 times 2 times 1 times 2 times 1 times 6 factorial. And then, let's cancel common terms. 6 factorial. What else? We have there 12, which is also the same as 4 times 3. We also have 8, but not all the 8. We will just divide 8 by 2 times 2, which is 4. So 8 divided by 4 there is 2. So you have there remaining 2. And that's it. So the numbers to multiply are 11 times 10 times 9 times 2 times 7. So the permutation for this is 13,860 different arrangements. Doing good? Well, the most important part here is that you know how to solve the problem. I'm just time pressuring you for a little extra thrill for this solving time. Let's try the second problem. How many 8-digit landline numbers can be formed using the digits 8998, 8229? 30 seconds, go. Time's up, mathletes. The answer here is 560 distinct landline numbers. Now, let's proceed with the solution. Remember our formula n factorial all over a factorial, b factorial, c factorial, and so on? Simply identify the number of objects there and then the number of objects repeated. So n is equal to 8. For a, we will be using 8 here as it appears 3 times. B is our 9 as it appears 3 times also, while C is 2 as it appears 2 times. Therefore, substitute this to your formula and you have 8 factorial over 3 factorial, 3 factorial, 2 factorial. Again, you may use your calculator if you have one. If none, let's simplify. Let's expand the numbers. So we have there 8 times 7 times 6 times 5 times 4 times 3 factorial over 3 factorial times 3 times 2 times 1 times 2 times 1. And cancel the common terms. We have there 3 factorial. Also, we can cancel 6. On the denominator, we have 3 times 2. Another one here is we could divide 4 by 2. And we have there 2. So multiply together 8, 7, 5, and 2. Therefore, the permutation for this is 560. Did you get the same? Well, I hope you do. Let's try the third problem. How many ordered arrangements can be formed using the letters in the word Philippines? How many ordered arrangements can be formed using the letters in the word Philippines? Go. Time's up, mathletes. Let's check your work. The answer here is 1,108,800. There are 1,108,800 distinct arrangements from the letters of the word Philippines. Did you get it? Let's check out the solution. For our solution, we just simply have to identify your N and the letter of the repeated object. So we have here N equals 11. Our A here represents P, which appears 3 times in Philippines. And our B represents I, that also appears 3 times in the Philippines. So there are only 2 letters repeated in the word Philippines. Ay ka, yang kaya. I told you, mathletes, our lesson is easy, right? Do not forget that in mathematics, practice is the key to mastery. So for you to be able to master our mathematical skills for today, don't forget to practice solving. So that we can say, ay ka, yako, ay ka, yamo, ay ka, yan natin to. Learn mathematics together and we will say, ay ka, yan naman pala. But do not forget that there are 2 permutations that we will be discussing for today. We are done with distinguishable and we are about to move forward to our second kind of permutation. But let's review first. Your distinguishable permutation is the arrangement of objects where there are some objects that are identical. The formula that we use is P equals N factorial over A factorial, B factorial, C factorial, and so on, where N is still the number of objects and your A, B, and C's are the number of repeated objects. Now, let's move on with the circular permutation. Circular permutation is the number of ways to arrange n distinct objects along a circle. Yes, our clue there is that we will be arranging them in a circular motion. And the formula to use here is simply P equals the quantity n minus 1 factorial. That's right. We will just have the value of our n and subtract it with 1 and get its factorial. So let's check why the formula is just like this. The minus 1 signifies a fixed object since all cyclic permutation of objects are equivalent. Cyclic meaning we will just be moving one position. So we have to have one fixed object. So let's have this example to further understand what just I said. How many different arrangements can 4 people be seated around a circular table? There are 4 people and we want to arrange them, right? So using the formula, we just said that you just have to put -1, n is 4. So the permutation is equal to the quantity 4 minus 1 factorial, which is equal to 3 factorial, which is equal to 6 ways. Take a look at the fixed position here. We fixed 1 at the top, okay? And then we simply rearrange the other 3s so that we will be forming different arrangements for this problem. So it could be 1, 2, 3, 4, 1, 2, 4, 3, 1, 3, 2, 4, 1, 3, 4, 2, 1, 4, 2, 3, and 1, 4, 3, 2. So there are 6 possible arrangements for this. Know that these arrangements are the same. That is why a fixed object is necessary. So take a look at this one. 1, 2, 3, 4. If we will not fix 1 at the top, and we will just be moving it on the right side, check that on the right side of 1 is still 2, and on the left side is still 4. So they are just the same. For the first arrangement, the left side of 1 is 4, the right side is 2. So what if we put 1 on the bottom? Still, you can see here that on its right side, it will still be 2, and on its left side, it will still be 4. Same thing if we move that 1 on the left side. Its right side will still be 2, and its left side is still 4. That's the importance of fixing one object in a circular arrangement. Get it? Now let's try another example. Example 2. In how many ways can 7 different colored horses be positioned in a carousel? So, to solve this problem, take note that carousel is actually in a circular arrangement. So we will be arranging the horses in circular motion. So we will use the circular permutation. Our n there is 7, and substitute it to the formula P is equal to the quantity n minus 1 factorial. We get quantity 7 minus 1 factorial. So the permutation is actually 6 factorial, or there are 720 ways to arrange those 7 different colored horses in a carousel. See, it's easy, right? Again, let's just review. For the first permutation, we call it the distinct or linear permutation. The formula we use is the permutation of n objects taken r at a time is equal to n factorial over the quantity n minus r factorial. But if n is equal to r, we simply have to get the n factorial. For the distinguishable permutation, where the objects are not unique, or there are objects that are not unique, we simply use P is equal to n factorial over A factorial, B factorial, C factorial, and so on. N is the number of objects, while A, B, C, and other variables represent the number of repeated objects. For the circular permutation, we use the formula P is equal to the quantity n minus 1 factorial. Just remember that we have to fix one object, n minus 1, then get its factorial. With all this, I guess you are ready for the 30 seconds challenge. Prepare your paper and pen, and let's try to solve the problems. Challenge 1. What formula will be used to solve the permutation of 6 objects taken 4 at a time? Is it this one, n factorial over the quantity n minus r factorial? Is it the second one, n factorial over a factorial, b factorial, c factorial? Or the third one, the quantity n minus 1 factorial. 30 seconds, go. And the answer is very good. It's the first one. N factorial over the quantity n minus r factorial. Remember, it is important that we really know which formula to use before solving your problem. Now, let's try challenge number 2. Solve the permutation of 6 objects taken 4 at a time. Go. And the answer is 360. For the solution, you will have this one. Use the formula, substitute the given, and solve the problem. The answer, 360. I hope you got it right. Now let's try challenge number 3. What type of permutation is shown below? P is equal to 9 factorial over 5 factorial, 3 factorial. Is it linear permutation, distinguishable permutation, or circular permutation? Go. The answer is very good. This is distinguishable permutation. For challenge 4, I want you to solve
P equals 9 factorial over 5 factorial, 3 factorial.
Go. The answer is 504. For the solution, we simply have to expand the factorial and solve the problem. And you will get here 9 times 8 times 7, which is 504. Doing great, mathletes. Let's try challenge 5. What type of permutation is shown below? P is equal to the quantity 7 minus 1 factorial. Is it linear permutation, distinguishable permutation, or circular permutation? Go. The answer is correct. It's circular permutation. Don't forget the fixed point. That's why we have -1. Now, for challenge 6, solve P equals the quantity 7 minus 1 factorial. Go! And what's your answer, mathletes? Good job! The answer here is 720. For the solution, we have here 7 minus 1, which is 6, and get its factorial. You have 6 times 5 times 4 times 3 times 2 times 1, which is 720. Wow, doing so good, mathletes. Let's try challenge number 7. What type of permutation is the given problem? Find the number of permutations of the letters of the word reference. What type of permutation is this? Linear permutation, distinguishable permutation, or circular permutation? Go! And what's your answer, mathletes? Good job! The answer here is distinguishable permutation because there are the same objects on the letters of the word reference. Now, it's time for you to solve. Challenge number 8. Find the number of permutations of the letters of the word reference. Go! Did you get 7,560 ways to arrange the letters of the word reference? Then you're doing just great. Don't forget our formula. P is equal to n factorial over a factorial b factorial. As you can see, we will only be using a and b because the only letters that appears for more than twice are R and E. R appears twice and E appears 4 times. So substituting this to your formula, you have 9 factorial over 2 factorial, 4 factorial. And simplifying, you will be able to get 9 times 8 times 7 times 3 times 5, which is 7,560 ways. Remember, mathletes, the 2 types of permutations that we discussed today: distinguishable permutation using the formula n factorial over a factorial, b factorial, c factorial, and so on, where n is equal to number of objects, while a, b, c, and other variables could be the number of repeated objects. While for your circular permutation, p is simply equal to the quantity n minus 1 factorial. Don't forget the fixed object. And of course, our main permutation of n objects taken r at a time is equal to n factorial over the quantity n minus r factorial. Or if n is equal to r, simply use n factorial. With all this in mind, I guess you are ready for our knowledge check. So, you are given 5 seconds to think of the answer for each of the question. Ready? So, shake a bit, and let's try to answer the problems. Number 1. It is the arrangement of objects where order matters. Arrangement of objects where order matters. Is it circular permutation, distinguishable permutation, permutation of n objects taken r at a time equals n factorial over the quantity n minus r factorial, permutation of n objects taken r at a time is equal to n factorial, or permutation? Go! The answer here is very good. This is permutation. Now let's try this second question. The permutation of n objects taken r at a time is blank. The permutation of n objects taken r at a time is blank. Which of these options is the answer? 5 seconds. Go. And what's your answer, mathletes? Good job! The answer here is the formula for permutation of n objects taken r at a time, which is equal to n factorial over the quantity n minus r factorial. Let's try the third one. Different objects n can be arranged taken all at a time is blank. Different objects n can be arranged taken all at a time is blank. Circular permutation, distinguishable permutation, permutation of n objects taken r at a time is equal to n factorial over the quantity n minus r factorial, or permutation of n objects taken r at a time is equal to n factorial, or permutation. Go! And the correct answer is very good. If we have the same number for n and r, we will just be considering the n factorial permutation of the objects. Now let's try the fourth one. It is the arrangement of a set of objects where there are objects that are identical. The clue word, there are identical objects. So again, with all the choices, which is the answer? The answer is very good. It is distinguishable objects. So remember, there are objects or some objects that are just the same. So you use distinguishable permutation. And last question. The number of ways to arrange n distinct objects along a circle is blank. The clue there, circle. Which could it be? Circular permutation, distinguishable permutation, permutation of n objects taken r at a time is equal to n factorial over the quantity n minus r factorial, permutation of n objects taken r at a time is equal to n factorial, or permutation. Go! And the correct answer is good job! It's circular permutation. Our clue there is the word circle. Remember, mathletes, in learning mathematics, ay kaya ko, ay kaya mo, and together, ay kaya natin to. Thank you for joining me here today, mathletes, and I hope to see you again. Goodbye!